So my name is Manoranjan Paul. It's not to be confused with Naruana Paul. All right. Manoranjan actually means entertainment. Entertainment plus education will be enlightenment. Entertainment without education would make me just a joker. So I looked up the thesaurus, and the words that I used to define a joker is a banana, a second banana, a top banana. I'm not sure what that means really. But also there's an interesting word which is called wisecracker. So I certainly like to be wise, and sometimes I've got to do this, right? So we all have to do this for like crack passwords and things for the work, the kinds of work that we do. And there's kind of an example of that. I certainly like to be wise. The Bible actually tells that he that wins souls is wise. So I am a Christian. People ask me, you're from India, so how come you're a Christian? But I am a third generation Christian, but I'm a born again believer as well. Some people may feel that to be elite. Others may think it is lame. Actually, it doesn't matter after 3 near-death calls. No, I am a Christian. So a couple of years ago, we founded, actually about 2 years ago, we founded Hackformers, which is an organization here in Austin. And Hackformers it has the mission of teaching security, teaching Christ, teaching security in Christ, and we actually have some stickers for guys who want to come and pick up some from us. I also write daily or like weekly, on every week on a daily basis. I write when I get a chance on my faith blog. So if you want to track me on my faith stuff, then that's where you would get a hold of my faith stuff. I'm an author, which is evidenced by some of these books. In fact, the official guide to the CSSLP is one of the books that I've donated to LastCon for them to raffle it away or give it as a prize at the end of the ceremony or at the end of this conference. So be there if you want to get one, and then if you win it, then I'll sign it for you. As for my day job, I'm the president and CEO of Secure Risk Solutions, which is a company that focuses on training, consulting, and products. But I have to backtrack a little bit. And I used to work here, I used to work here at Dell, where I used to stop these guys from trying to do these things, like drop tables, right, SQL injection attacks, or cross-site scripting attacks, cross-site request forgery attacks, which actually looks much better on a t-shirt than in code. And, but even before that, I used to work actually at the Bimini Biological Field Station as a shark researcher, and I used to work for this guy, Samuel Gruber, who is the founder of the American Ellsworth Brand Society. And so he's featured like in Discovery Channel, Shark Week, and all that stuff. So I used to work directly under him as a research student. And you know that I'm a shark junkie with just the iPhone apps. Everything that's got to do with sharks is, is something that I like. So I kind of go by the handles, the shark. But when I'm not doing shark stuff, or I'm not doing security stuff, or the Hackformer stuff, I'm actually doing this. So anybody can tell me what, anybody can tell me what the symbol represents? It's got like 5 animals in there.
Martial arts.
Martial arts, which martial art? The Shaolin martial arts, right? And that's Grandmaster Sinquante. And we are students. My son and I are actually students of Grandmaster Sinquante. We're like one removed, so his student is our master. Master Joe Schaefer, Senior Master Joe Schaefer. And my son and I just recently were given or awarded the black belt, actually, August 22nd. All right, so don't mess with my son, because I am so proud to tell you this. My son is the youngest American in Shaolin Kung Fu. So he was actually featured in the news to have received the black belt. He started when he was about 3.5 years old, and he was there in the news for his achievements. So I am so proud. I have a second son as well, who's about 20 months old, so he would end up becoming the youngest black belt if he ends up turning to do something like this, right? So, I don't know, so they're the families and the reasons to why I do what I do. My son once asked me if I was famous. Yes, I was in the news, on the WikiLeaks, reporting on the issue because it was a local issue that we were talking about. But even more, Google once actually did this to me, and they put my name on Playboy. Now, the way it works is Google indexed 2 different names. It was Keith Mano and Paul Erdman. But then when it comes out as somebody searching for Mano Paul, it would actually come up with this picture. This is not me, just so to clarify, all right? So who am I? I'm a Christian. I'm an author, a biologist, a CEO in The Shark. I love my savior, love my spouse, love my sons, love Shaolin, love sharks, and I love security. So with that said, I'm Mano the Shark Paul, and my Twitter handle is @ManoPaul. So if you guys are tweeting, then if you're saying something good, I'll retweet it. If you're saying something bad, then I won't retweet it. But we're here to actually talk about iOS reversing and basically decrypting iOS apps. And so the rest of the talk is basically on, I'm going to focus on this, on the tools and the techniques that we're going to use to be able to decrypt apps that we get from the App Store, or any apps that we download and get on our phones or our iPads and our iDevices. Now, the talk, I'm going to go fast early, giving you the methodology. Then I'm going to do a manual demo, and then at the end of the talk, I'll also have a script that I've written that kind of automates most of the processes that I'll go through, and you'll see the benefit of the script once you see how onerous it is to go through the manual reversing process itself. So this is the disclaimer. This is only for educational purposes, which means if you're like a diabetic in a candy store, right, you can look but you can't touch or you can't eat, right? So do it for the betterment of security. And I don't claim to be an iOS expert, nor do I claim to be one. I'm not one, I know that, but I dabble with it and I have found findings, and I enjoy looking into things and discovering new things for the betterment of security. At LastCon, this is I think my second or third time that I've been speaking. And I kind of hats off to LastCon because it's one of the best conferences, that I think in the country that we have for security professionals. And so Austin being rife with security professionals, it's a great place to be in. And so it's glad that I'm here, and glad that you guys are here as well. So what is iOS? It actually came from the word iPhone OS, but it's morphed into being not just tied to the iPhone itself. Developed by Apple, runs on most of the iDevices. The critical aspect of iOS, though, is it actually operates on what's called a layered architecture, which means the iOS acts as an intermediary between the hardware and the app itself that you're running. So in order for us to really reverse the app or to find information about the app, what we'll end up having to do is we'll have to hook into that running processes in memory and grab some information out. And that's kind of how we'll go about doing this whole decryption process. Now, iOS apps itself, when you download from the App Store, by default, they come encrypted. So you're not going to get any source code. You're going to get it only in binary form. And you may have certain times local storage like SQLite and other databases that are bundled with the app, which has certain sensitive information. And that's one place to do your recon and start researching, is to find out what information is out there in a SQLite database, or if it's going to be using a managed object model, a MOM object model for its data storage. You can inspect that as well. And you may get some information out of it. But really, this is about more of what do we do to get information out of the binary itself? How do I decrypt that encrypted binary that is in place? So reversing, going back in the life cycle, what you really need is you need to have the tools, you need to know some techniques. And in this talk, I'm going to focus primarily on the discovery part. So to be able to decrypt information and get access to app design, the logic, the API calls that are in there, if there's any data that is sensitive that's in the app itself, that kind of stuff. I'm not actually going to be doing a demo on the tampering part, which is the patching. I'll do a little bit of patching, but I'm not going to do the patching, but you have to take the entitlement list file out, and then you have to re-sign and then code sign it with your developer profile to relaunch it into the app. Because of the interest of time, we won't be able to do it. There is another runtime kind of analysis that you could do, which is called method whistling. You could use frameworks like Cycrypt and other things, which is a JavaScript framework for Objective-C. And those frameworks will be used for method whistling, and so that could give you more runtime modification. But if you want permanent modification, then you really have to get the app, you have to patch it, you have to then re-sign it, and then redeploy it. And when you redeploy it, you have to make sure that the code signatures are the ones that are applicable so that the app can run back in the device itself. So that will be probably another talk that I'll be doing sometime later. But for now, we'll just look at the first part of it. For us, in terms of the prereqs itself as to what you need for the app, for reversing iOS apps, you'll of course have to have your iPhone, your jailbroken device, or the hardware itself. Whatever target app that you're going to do, whatever target app you're attempting to reverse. And then a lot of coffee, a lot of Red Bull, booze, probably combination of all three together. I don't know. So it takes a lot of long nights sometimes, and you just have to do what it takes to be. And security professionals, we're kind of weird. We're like the bulldog that we really want to go after that bone and don't want to let go till we get it. And it sometimes just keeps you on like long nights you'll be working on these stuff. So if you're doing stuff like reversing and other stuff like that. Tools itself, as I said, of course, for you to be able to get on access to the jailbroken device. Class dump is one tool that I'll show you over here, which will get all the class information. Xcode itself comes with a lot of the tools that is necessary for us to be able to inspect the app. So Apple gives us the tools that are necessary. NM will load all the symbols. OTool is one of the most powerful tools that I can look into the header information of the file. I can look into the information, into the way the app itself is designed, the crypt information that is there for it as to how it gets encrypted. Right? And then of course scripts, which is like any hacker or any pen test or any security professional is probably going to be writing their own scripts to be able to do so, or you could use some of the stuff that has been already done in this space. So the technique, first install the target app on your iDevice. In the Mac OS, of course, iTunes itself, you could get it from iTunes, install it on your app on your device, whether it's on Mac or in Windows. iFunbox, anybody's used that before? So you can kind of look into the raw file system itself using iFunbox. Or if you're on the device itself, you could use the install IPA and then be able to install the app on the device itself. So there are a couple of ways we get the app on the device. Once we have it, then we make a backup of the app just for general good practice, because most of the times when you're going to be patching or looking at binary analysis of a file, and then you're going to try to change some of the stuff in that, you're going to most likely overwrite some stuff, and you probably didn't intend to overwrite, and then you don't have a backup, you're kind of screwed, you've got to go get that app again. So do a backup, just general good practice. And then you copy the app itself to an application to some directory, like a reversing directory or something that you can call, in your system itself, in your desktop or your MacBook, and then you rename the IPA. Now the IPA is the extension that you get as you download the file from the App Store, but then you rename that to a zip file. It's really just a compressed file. You rename it to a zip file, and then you unzip it to generate what's called the payload. It has all the information that you need for that app itself, for that binary to run. So you'd unzip it. The default place you get that from, it would be from Music, iTunes, Media, Mobile Apps, and then you'll see whatever apps you've installed are the ones that you would get from that directory, and then unzip. Then we would try to actually extract the class information using the class dumpz tool. When you do that, what you're going to actually see is the terminal is going to report something like this. Warning, this part of the binary is actually encrypted, okay, which is expected, we know. Usually the result will not be meaningful to you, but then I love that last line. Try to provide an unencrypted version. So that was my motivator as to why I need to provide this class file, this class dumpz. Now it's being prestigious. So, so it tells you that it's actually looking, if you want to use this class dumpz tool, then it's looking for an unencrypted file for you to get some meaningful information. So the next part of this is really to see what do I need to take this encrypted file into an unencrypted state. In order for us to verify that it's truly encrypted, if you just open the file that you piped out, that file, that results of the class dumpz, you'd see the stuff over here, which is like protocol, XX, encrypted protocol. You really won't see anything that is in there that's meaningful for us to be able to look at the file and see, or the app itself, and see what the app is doing. So the first thing we do then is to actually look at step one, would be to determine the architecture on which this file is going to be compiled and on which architectures this app is going to run. So the OTool VH, or the verbose header switch, would actually give you information, and it kind of gives you the information saying that it's going to run on the ARM v7 for iPhone 4S and above, or ARM v7S, which is 5 and above, I believe. But then there's something interesting over there which says PIE, which is, anybody know what that stands for? How many of you know what ASLR is? Advanced address space layout randomization. So every time the app runs, it's going to get its own memory space. So PIE is Apple's version of ASLR, which essentially is program independent, position independent execution. So each time the app runs, the base address in which the app is going to run is different, and it's basically to defeat people from being able to completely reverse it. So you need to really go into the process, hook into the process, get that base address, and then be able to see. So that tells me that now since this app is encrypted, it also is having protection of ASLR, or in this case, PIE. Once we have the information about the crypt, we know that it's encrypted, we try to steal the crypt, we try to extract the cryptic information as to where is it actually encrypted. So in this case, it tells me that the crypt ID is 1, which means it's encrypted. There's a crypt offset of 8192, which is, in hex code, that'll be 2000. And there's a crypt size as well that is mentioned. Now, I also would probably go about not just doing a grep on the crypt itself, but I would go about and see if I can load all the libraries that are running on this app using the OTool command, or the tool, and then look for LC encryption info, because it also gives me another piece of information which is called command size. And that becomes important because I use command size to find out where exactly this crypt ID is in the binary. So we go get the crypt information, and then you actually have to open the binary, the app, in some hex editor. So you could use the 0xED editor, or you could use hexedit. Any editor that could do hex editing, you'd be able to, and you're going to basically get the hexadecimal representation of the application of the binary itself. So we load the binary in the hex editor, but then where in the hex is the script ID, right? For us to be able to go find that information, we go back and look at what we found out earlier, where you saw this information. LC encryption information, which says that for this command, LC encryption info, that comes out as 21, I guess, what is that? The hexadecimal representation for that is 21 million, right? And then you have, for the 4 bytes of size, which is for 20, that's going to translate to be 14. For the 4 bytes of offset, for crypt offset, which is 8192, that's basically 2000 in hex space, right? So we have all that information, which means I could take this information, get the hex values for it, and then search for the hex value inside my editor, and then find out where the script ID is, and that's the one that I'm going to replace. So Once you get that information, seek and you will find, which is look for that representation, which is basically these hex values strung together, and you would find out that there is that crypt ID right there at 01. So we then find that's the one that's giving you the encryption information, or it's saying that the file is encrypted, so we want to have to overwrite it. So make sure that your hex editor is in overwrite mode, change the crypt ID to 0 from 01 to 0. Once you overwrite it, you go back, save the binary, and then you do a grep on that crypt, and you basically would say that the crypt ID is no longer active, which means it doesn't require now for it to be decrypted when it's going to run. Even after having said that, though, we still haven't done anything to decrypt the file itself. We just changed a flag to say that it doesn't require decryption routine when it's in execution mode. So in order to find that information to be able to really decrypt that app itself, we then have to find out what that base address is where this file is going to execute. So when we look at the base address, determining the base address would be basically to look at hooking into the file. So you run the app in your phone or device, or in your iDevice, and basically find out what the processes are, grep for the app. It'll give you its process ID. Then GDB into that process ID to attach a debugger into that running app process. Once you GDB into that, I'll actually show this in demo as well. You could then find out, using the info on the shared libraries that are loaded, what that base ID is, and the very first one will tell you what that base address is. So in this case, we have 1E hex 1E1000, right, as the hex. Now, earlier I mentioned that the virtual machine address in load command 1 section of the app itself, it has what's called a VM address. Now, the VM address is basically the starting address when it's going to be in execution mode. But with the phone is not right now the app is not in execution mode, so we have to still keep that in mind. But if you try to read off that from the phone, you're going to get an access denied. I cannot read any access from memory, which means it confirms that the base address is where that app is actually loading. So then when you go and try to actually load off and read memory from the base address, you basically get the information that you need to decrypt from, or you need to dump out. So what I do then is to do, there's a little bit of cryptic calculations over here, where all I'm really doing is I'm going to do a dump memory. In order for me to do a dump memory to some bin file, I need to get the start address and the ending address. The start address for us in this case would be that base address plus whatever cryptographic offset is there. So in this situation, it'll be the base address of 1E1000 and then the cryptographic information, the offset that we have of 2000. The ending address would be then, in addition to the start from where start plus offset, plus what is the size of the crypt file itself, that file that's going to be decrypted and loaded in memory. And so we end up taking that, adding that to it. So you now have what's called a starting address and an ending address. Once you do that, you basically just put that into your dump memory at GDB, get that memory dumped out into a bin file, in this case, a bin file that represents over here, and then quit out of that GDB or detach from that process. And then you now have that dumped, decrypted state of that file in memory, persisted on the disk. Now you then have to transfer it from the phone over to your device so that you can then patch the app that you overwrote first, changing the crypt ID. So you could use like CyberDuck, or you could use any kind of FTP client, or you could just use the SCP, and then recursively just dump the whole thing off to your desktop. So once you transfer the memory over to your desktop, at this point you basically go about editing your binary. You actually open up the file that you just downloaded, which is in decrypted state, copy, select all, copy the whole thing, and then open the original ID. Now in this case, I told you have a virtual memory address, right? So when the app runs, it's going to actually take that into account as well. So the offset where I'm going to have to overwrite the binary would be the virtual memory address plus the cryptographic offset. Many times you'd find out we forget about the virtual memory address, and you would actually overwrite the file and it won't actually give you anything. It'll give you a segmentation fault or something else, and you're like, oh, I missed something because I didn't actually overwrite the right place in memory. So you'd actually have to take into account the virtual memory address, the crypt offset, and then in this case it's 1000 plus 2000, so it gives you hex 3000, and override the memory. Try extracting the class information from the app, and once you do it, this is the encrypted what you saw earlier, and you'll start seeing actually information that's decrypted. So if you don't trust me that this is how it works, let's see if we can do this as a demo, right? So I'm going to brave the demo gods, as they say, and I'm going to try to do a live demo over here. I'm tired of people who are just showing videos of their stuff, but I don't want to conform to the norm. Generally, I'm like that. So let's see if we can do a demo. All right? So first and foremost, let me get out of this here and go back to my Mac.
So this took you how long
As in,
up to this point, how many nights?
it took a couple of nights, and then the script part of it, I ended my script, which I'm going to give away at the end of this, at 1:41 in the other room is when I finished writing the script. So, it's not been tested or anything, but you'll see it in action in a couple of minutes. So let's get this going. And so first and foremost, let me find out what my config is, just to verify that it's the same that I took earlier. So my local is 10.247, so MacBook, that is correct. And then on my iPhone, I have 10.247.3 and 4.5. So, all right. So let's go over here and let's do, first thing we want to do is let's get the app, and I'm going to last con demo music. I don't know why mobile apps is under music, but it is there under iTunes Media, mobile apps, and then there's a run at 10K app that I'm going to copy. I'm going to move it over to my desktop into last con demo. I'm going to paste it over there. Right. Now I told you that the very first thing we want to do is then just basically unzip this file, or actually rename it to zip. Use zip, open the zip, and it gives you the payload. So we have the payload and the binary stuff over here. There's a bundle, so you'll have to show package contents, and you'll actually see, oh, I don't mean to play music right now, sorry. Clicking too fast, I guess. It's chiming around. And you see that that's the app. That's the Unix executable, or the app that I want to look at. Now, if I just do class dumz on this app, you would see what I was talking about earlier. All the stuff, it basically comes out and it says it's all encrypted, and really there's not much information. So I need to provide it an unencrypted version. So in order for me to do that, I'll open this app first, and step one would be to edit the binary. And I'm going to look for the crypt ID. But in order for me to look for the crypt ID, I told you earlier I need to find out some information as to where that crypt ID is. So for me to look at where the crypt ID is, I'll do otool version header and give it this app. And this gives me again clarification. It tells me that it's position independent execution. It's supporting ARM v7 and ARM v7s as the architectures. So it can compile to two different architectures and work on those two. And I want to also find out crypt information. And in order for me to do that, I'll do the otool load all the commands, which is the switch for L. Okay, and grab the crypt information. So I've got grep crypt. It kind of actually tells me the crypt offset over here is 16384, which is hexadecimal 4000, and then crypt size, whatever that size is going to be. The crypt ID is actually 1, which means this file is encrypted. So in fact, let's verify one other information, which is without the crypt information. Let me look for loading all commands, and if you go up to load command 1, there you go. To load command 1, the virtual memory address, which is important, that information we need to see. So that's 4000, it's at hex 4000. So just remember that for the time being. We'll come back to that, and we'll have to look at the crypt information here, getting crypt. So it's 16384, which is hex 4000, and then this crypt ID is what we want to change. So in order for me to actually edit the binary over here, I would search for that string 21,000, 6, 14, 1, 2, 3, 4, 5, 6. And that actually gives me this information. So it is 14,000. And then if you notice, this crypt file tells me that the crypt offset is 16384. So if I do a hex on 16384, it actually is offset, it's hexadecimally represented as 0x4000. So the next one over here confirms that it is 4000. All right? So this string. And then the crypt size, 4784128, the hexadecimal representation of that is 49, what is that? 49, I don't know, all right? But this is the value that we're interested in. So put your hex editor in overwrite mode. Make sure you do this. It often defaults at insert mode. You don't want to do that because it'll change your binary and it'll actually corrupt it. So you put it in override mode, and I changed that binary over there to 0, all right? Now, I said that it actually showed me that it had it in 2 places. The second place where I'm going to find that information is back to that 49,000, and I have another location to change. So I've changed 2 locations. Now, in order for me to go back and verify if that changed, it's changed, and I've got that the crypt ID is now 0. All right. Still, again, we haven't actually changed the binary itself. We've just removed the check for saying that it needs to be looking at the decryption routine when it's in execution mode. So we get the script information. Now, at this point, I need to be able to go back and get the decrypted file from the decrypted binary from memory. So I'd actually have to SSH into my phone. And what was the address? 10.247.3.45. All right. And it's going to ask me for my password. Now I have access to the file system on the phone, so I'm actually going to remove this, what I did earlier, so it's not, I'm not cheating you guys. All right? So all we have right now is just that phone information. So at this point, I would look to see if there's an app, if the app itself is running. If I have not started the app, I won't see it. If I have the app in process memory, it's going to be running. And it does, I run the app over here. It's an app that's a run 10K app. It's running in process ID 572. So hook into that, 572. And it's going to attach to the process, and it's going to try to load some libraries, things that it can find, what it can't find. And I'll kind of give this ... for a while, so we can talk about the weather, we can talk about where you like to go for vacation, and that's, it'll be done in a minute here, so maybe less.
You had two flags to set because that was a fat binary?
Yes, right. So in some cases, you'll actually just have one. So in this case, it's Mac and a thing. In fact, you could get away if you're just doing it for that phone. You could just change the first one for ARM-V7, and you wouldn't have to change the other one, but it's always better to do both. And so, all right? So we've got some symbols loaded over here. Now, if I told you earlier that the memory address said 4,000, so, right? So if I was to go and try to read off from that starting address of 4,000, 64 bytes, it's going to tell me I can't access memory, which means when it's running in place, it's actually running in a base address, which is different from the virtual memory address. In order for me to find that, I would go to actually look at all these shared libraries that got loaded, and the very first one is actually the shared library for the app itself. So if you go down, it's got like 200 shared libraries or something that it calls, pretty bloated app. And if you go down to the very first one, you see that it is 03, that's the address we need. Now to verify that that's the address and I can read from that memory, I would do the same command except that I would change this address space. And now I can read some data from memory. So I'm getting 64 bytes of data from that memory space. So I've got to now dump this memory over to to the disk and then actually transfer it over for me to patch the app itself. Now in order for me to do that, I told you we need to do some cryptic calculations. So I've written a helper method or a helper, let me see if I have it open yeah. It's a crypt calc helper workbook, as scientific as this can be, right? And it has the crypt offset, which is 16384, which is from here, 16384, and then 4784128 is the crypt size. So those are the two values, what the hexadecimal representations are. The base address is going to be what was loaded in memory, and this is going to be actually different every time you run the app, right? Every time you turn off the app and you run it. So you have to really do this on the fly, or you've got to learn, you've got to figure out what that loading address is. So the base address is really your loading address. In this case, it is 3C000. So you put that in there. You would then starting address is going to be that plus the crypt offset, which gives me a starting address of 40,000 in hex. All right. Now once I have the starting address there, I also need to find the ending address, and ending address is base address plus crypt off plus crypt size. And so that basically is 40,000 plus whatever the script size value was, which gives me 4D and then the string of zeros behind that. So the command that I got to run now is dump memory and dump it to some. So let's do this. So this is, I'm going to say lastcon demo memdump, all right? and we copy this, run it here, and I can now quit out of GDB. Yes, I want to quit. I'll do an LSL to see if that file is there. And you see that that file is there, which is now decrypted binary that has been persisted to disk. It's last con demo, run a10k mem dump, right? And the size here is very important. If you're not calculated the correct offsets and the starting and the starting and the ending address, this size will be different, which means you actually didn't get the right amount of data out of memory. All right? So this size should match the previous, so 4784128 should be exactly the same size, 4784128, as to what that crypt size was. So we've got this file now in memory, or actually in the disk, and I'm going to just transfer it over to my local box. Monopole at 10 dot, what was that address? 247.45, and then I'm just going to move it over to the users, monopole, desktop. Asking, there's a last con demo folder. All right, so I'm just basically copying this over to my desktop last con demo folder, and once I run this here, are you sure you want to continue? Did I not give the right? Right. No, maybe you're right. Permissions denied, of course. So let me, yeah. Damn it. Yeah. And they changed my IP on me.
No, it's just out 26.
26, yeah, okay, all right. You guys are sleeping or what? 26. All right? Oh, actually, it's not there in that location, so I need to. Okay, there you go. I was root, and then it's going to transfer that file over. Once the transfer is done, now we have that last com done file over here. So we have the decrypted version of the file on our app. Basically, what we then have to do is go back into this, payload, show bundle contents, open the app again in an hex editor. I think I already have that open. And I'm going to open this binary file as well. So, because I need to copy the contents out of that. So open. So I'm going to select all, copy all. Now this offset that I was talking about is going to be the offset where I need to overwrite it is the virtual memory address plus the crypt offset. So that's virtual memory address was 4,000, crypt offset was another 4,000, that'll give me hex 8,000. So when I go over to hex 8,000, I would see that this file over here is encrypted, so I'm going to actually overwrite it with what I copied, and I would save this information onto the app itself. So now that executable is actually got a decrypted version of the app, of the binary. It also doesn't require the check for decryption or encryption because we changed the crypt ID flag. And so at this point, if we were to go back here and run the class dump tool, class dump on this file, what was encrypted is out now in clear text for you to see information as you go in and then say, at this point, you're basically going to look at it and see what APIs it's calling, what methods it's calling. You pretty much have the whole app and runs all the information that you need to know. So there you go with regard to the manual process of doing it. And I told you earlier that I will release a script or a tool. So let's see if the script actually works, because at 1:41 it was completed. It's about about an hour ago, a little less than an hour ago, in the other room. So let's see if we can get to that now. So CD to, let me just do this first. CD to documents. Oh, I'm on the phone, sorry. So I got a ton of scripts here. I did this in like multiple scripts, and then I put all in one script. So that's the one we will actually look at today. And you'll have that all in one script, right? So here it's telling me specify the directory where the app is. So you saw what I had to do to actually get this app onto this, rename it, all that stuff, right? So I don't want to do it. So I'm going to actually put this app back. Good thing is we took a backup, or did I not take a backup? Probably not. So let's actually kill all this. Move this to trash. I'm going to hold on to this bin so we could do it again, but I don't need that. I'm going to remove this. I don't need the IPs. Right now I'm going to actually move that away as well. And into this last con directory, we'll go to music, iTunes, media, mobile, run at 10K, the same app. Go to desktop, last con. So I'll leave it in the IPA state because the script itself will do this the zipping, renaming into zip, creating all the backup folders, the reversing folders, and all that for you. So it's saying, give me the directory where this app is. I put the directory in. That's the location where the app is. It's going to then ask input the name of the app that you wish to reverse. And that's going to be run at 10k.ipa. And that's what it is. And I enter. It's creating a backup directory. It's creating... All right, so what the script really did is it created a backup directory, and then it actually made a copy of that in there, and then it created a zip version of the file, opened it, so you have now the reversing directory with the payload, and then it ran the class dumpz tool against that payload to say that it's now encrypted. So the script then comes and halts here for me to come back and say, now that you have this information, it's all that stuff that we're manually doing, it's over here. So now to decrypt the app, open the app in a hex editor and overwrite. Did you overwrite that? So let's do that. This is the part that I'm actually still working on automating. It probably will be done soon, but I didn't have the time to finish this Cryptid overwriting, but it should be a matter of about 30 seconds here to change that value. So open, find the value here is 1, overwrite it to 0, and then find that same value again because it's 2 locations that you would find that for this binary, overwrite 0. All right, save that file. So I'll save this file. Let's actually get rid of that. Let's get rid of this as well. And did you overwrite the crypt ID? So, yes, I did. Now it comes back and verifies and it says, yes, that file was overwritten and now the crypt ID is not set. All right, so are the crypt IDs overwritten? We verified it. Yes, it is overwritten. Now it's time to actually build the memory dump command, connect to the remote device using SSH, run the app on the device and attach GDB to the process, what we just did. Once you dump the memory, quit that, and then SCP back it. So what this is really doing is all that cryptic calculation that we were manually having to do, right? Instead of having to do that, the script actually would do that calculation for you. In this case, let me do the file that I want to overwrite it to is like script run 10k mem dump or something like that. Okay? And it tells me, give me the base address for GDB. I would have had to hook into that process, get the base address, and we saw from the previous one what that base address was, which was, what was the base address? Since I didn't change the, that's not what I was wanting to open. There you go. So the base address in this case is going to be 03x, which you can find by hooking in. Specify the crypt offset 16384. Specify the crypt size 4784128. And actually builds that string for you. It does the calculations. It tells you as to what that string needs to be. So now you actually take this. If you run that in your GDB process, dump that out, you transfer it. If you've done it, now since we have already done it in the previous manual example, I'm not going to do it again, but trust me, you could do it, and then you would say, yes, I dumped it. And then did you dump it? Yes, next we need to find the virtual memory address. So shall we continue? VM address, we know that's 4000, which you can look at the otool L app name command. And if you don't, if you just go up and you'll be able to see that for 4000 as the virtual memory address. There you go. So load command 1, virtual memory address is the same 4000. So you come here, specify the virtual memory address. This is going to be 4000 in hex. Specify the memory dump file. So this, all that stuff that I had to open the memory file and decrypt and all that, so like overwrite. I'm just going to actually specify this file is the one that I want to write from. And it's saying patching the app. It opens it at whatever address space using the app has been patched. Once the app is patched, now try to run the class information again. Is the app patched? So if this failed, you would say no. Since it's patched, it says app has now been patched. You say yes. And it's decrypted out in memory. So this basically it then prints out the shark has bitten, woot. And you may clap now, and if you felt that was sweet, you may tweet. So that stuff is going to be out there on GitHub by the end of the day. So it's not out there yet, so I will make sure that I get that over to you. And so let's go back to this. So the live demo actually went on okay, I guess. That's the location, github.com, monopol. And credit where credit is due. There's some very good research and stuff that has been done. I use a lot of these resources. RC64 blog is an excellent resource, and then the Swiss Cyberstorm talk that Julian gave was a very good one as well. So there's more information out there. What was all this is they talk about it from a manual process. I was getting tired of doing it every time manually, so I wrote the script. Now the script is available for you guys, and but the script is not, so I am a software security guy and I teach about software security. I teach about good programming practices. I violated every single rule because I hacked that thing together. So there's like debug statements in there, there is no try-catch, no error handling, none of that stuff, right? So if in case you see it and you're like, don't use that as your model for good programming practices, all right? So take it and then extend it and expand it. So if you like the presentation or you did not like the presentation, you have other needs for your company, security program development, which is my background of product development or awareness training education, then you can contact me. Otherwise, have a good day and thank you all for finally coming. That's how you get a hold of me. LinkedIn, after the passwords are expired, had been exposed, I was wondering if I should say unLinkedIn, but yeah, so it's LinkedIn. I have a LinkedIn profile. I've got Facebook and Twitter, and Twitter is where I do most of the security, updates and things like that, and that's my address. So, ciao.